Good afternoon, everyone. So today I am going to explain you about an Kruskal's lab program. So here the question is, find the minimum spanning tree of a given connected undirected graph. So the graph what you are considering as an input, it should be an connected undirected graph. Okay, specifically they are only telling for what type of the graph you need to construct the minimum spanning tree. So make sure that whatever the graph you are considering, it is an connected undirected graph. Okay, then using the Kruskal's algorithm, and also explicitly they are telling that you need to use the union and the find algorithms in your program. So already I told you what is the purpose of using an union and an find function. Find function is used to find out the root of a given node or the vertex, and union is used to join the two subtree into a single subtree. That is the purpose of using the find and the union function. So now let us consider your lab program. So I am considering this particular graph. So where this graph is an connected undirected graph with an cost in for every edges, and you will be having the 5 nodes A, B, C, D and the E. Okay, so come to this initial declarations. What we are doing here is we are considering the max. So max here is nothing but the size of your matrix, and n represent the number of the vertices, and the cost of this is represents the cost matrix. Here you are not considering the adjacency matrix, you are considering the cost matrix, and this is a single dimensional array you are considering, that is the parent. So this particular array is used for that is for finding the root, that is find function. Union and find is there, no? In order to find out which is the root of an given particular node or the vertices, you will be using this array. That is, initially you make all that. How many vertices are there? 5 vertices are there. Therefore initially make for all of them as an 0. Okay, so that is where you will be using this particular parent array. Okay, then come to the main. And one more thing here, so whatever your class you are declaring here, public class, prims class, so this is a name of your file also, because this is the class which has a main program. So file name of your file should also be an same, that is prims class. So in the main function we are calling 2 more functions. One is a read matrix function, just to read the matrix, and the other one is a Kruskal in order to find out the minimum spanning tree. Now we will go for an read matrix. So what is there in the read matrix is just you are reading the matrix. So that is enter the number of the nodes, that is 5 in this for this particular graph. Then the enter the cost adjacency matrix. So you need to enter what is the cost, that is A to B it is 5, and all diagonal elements are 0, 0. You remember this, whenever you will be entering any of the matrix, the diagonal elements we are considering it as an 0 only. Therefore, and A to C there is no path, A to C there is no path, so it is 999, and A to D is 6. So enter the cost adjacency matrix. Then after that what we are doing here, so if the cost of ij is equal to 0, means if it is a diagonal element anywhere, if you are considering the cost of ij as an 0, then make that entry as an 999. So here see, initially the diagonal elements was 0, now I am making the diagonal elements as a 999. So what is the purpose of changing this diagonal elements from 0 to the 999 is that, so here Kruskal's algorithm what we are doing, we are arranging all of you know that how it works. We will arrange all the edges according to their increasing order of their edges, and first initially we will consider the edge with the least cost, that will be added to the MST. This will be continued, okay, until the number of the edges are 1 less than the number of the vertices. So minimum edge we are considering. So suppose if I take this diagonal elements values as a 0, 0, then every iteration this 0 itself will be the minimum cost edge. So but A to A, the edge will be an 0. There is no edge from A to A. That is the reason we have taken it as a 0. But when I'll apply this particular algorithm, since we are searching for a minimum cost edge, always in the each iteration we'll go for this 0 only, because it's a minimum cost edge. To avoid that one, so we are making it as an 999. Okay, or if you want, you can take it as a 3449 also. That is what we are doing it in a read matrix. Now come to this Kruskal's function. So in this one, here some variables we are declaring a, b, u, v, initially all are 0, and here one more variable we are declaring, that is a any number of the edges. Why we are considering this any? That is because when we have to stop this algorithm, when the number of the edges is 1 less than the number of the vertices, suppose if the number of the vertices are 5, then when we have to stop, when any will become an 4, then I have to stop. So that is the reason we have considered how many edges we have added to the MST, and the min cost we are considering initially as a 0. So min cost is a variable which will give you what is a final minimum cost of your given graph of an MST. Okay, then what we are doing here, while any, what is my initial value, we have taken any as a 1. Okay, 1 is less than n. What is my n? Number of the vertices, which is 5. Yes, 1 is less than the 5, then therefore I will enter into this. So initially my I is equal to 1, min is equal to 999, and j is equal to 1. See here, this here I am showing you the tracing. So I is equal to 1, j is equal to 1, and what is my min? Min is also equal to 999. Then I am checking that if the cost of ij, what is my ij value? 11. 11 means this one, AA. 11 is this entry. Okay, is this 999 is less than the min? What is my min we have taken? It is also a 999. Is this 999 is less than 999? No, it is false. That means I will not enter into this one. So which one will be incremented? J value will be an incremented. So now I is equal to 1 and j is equal to 2. Again I am checking what is the cost of 1, 2. So is the cost of the ij is less than the minimum. So what is 1, 2? 1, 2 is nothing but 5. Is 5 is less than, so here I am checking cost of an 1, 2 is less than the min. Min is 999 and cost of 1, 2 is 1, 2 is 5. Therefore whether the 5 is less than the 999, yes, it is less than the 999. Therefore what I am doing, I am considering the 5 as a minimum. So min will become cost of 1, 2, and a, b is nothing but uv is equal to ij. What is my I is 1, and what is my j? J is 2. So it is 1, 2. I value is 1 and j value is a 2. Again what I will do, again I will increment the value of the j by 1. So what is my I value? 1, and what is my j value? 3. Now again I am checking 1, 3. What is 1, 3? It is 999. So is it is less than the 5? No. Again I will increment the value of the j. Inner for loop has to get over now first. So I value will be 1 only, j value will move from 1, 2, 3, 4, 5 like that. Okay, now 1, 4. What I am doing? 1, 4. What is the value? 6. E6 is less than the min. What is my previous min I am having? It is 5, no? Here we have updated it as a 5. So E6 is less than the 5 we are checking, no. Then again I will check for the 1, 5. So that is 1, 5 entry. It is 999. Is 999 is less than 5? I will check, no. Then what I will do, again I cannot increment the j value because j value already reached its upper bound. Therefore now I will increment the value of the I. That means now I am initially I have pointed the first row and now I am considering the second row. I is equal to 2 means I am considering the second row. Again I will check that second row which is the minimum value. So now what is I value? 2, j value is 1. So 2, 1. What is the 2, 1 entry? 5. Is 5 is less than the min? So no. Then I will go for 1, 2. That is 2, 2. 2, 2. 999 is less than? No. Then 2, 3. So is 1 is less than the 5. What is 2, 3? 2, 3 is 1. Is 1 is less than the 5? Yes. If it is true, then I will enter into this Now min is equal to an cost of the 2 3, that is 1, and AU is, that is 2 3. A is equal to 2 and V is equal to 3. So that is what we have done here. Again what I will do, again I will increment the I is 2 and 4. That means I am checking for this 2 and 4 entry. 3, is it is less than 1? No. Like that I will move here. Again what I will do, once I will finish the j is equal to 5, again I will increment the value of the I is equal to 3. That means I am going in a third row. So entirely in these two for loops what we are doing here is, we are checking that in the entire all these entry, which is the minimum edge you are having. So when I will go through this one, which is the minimum edge we are having, that is this one. So 1 means what it is? 2, 3. So 2, 3 is the final minimum cost edge we are getting after this first iteration. So what is my UV value then? UV value or the AB value is nothing but a 2, 3. That is an second row, third column. Second row, third column. So it is 2, 3. So 2, 3 is nothing but your UV or the AB. Then what I am doing, I am calling after this finishes. So what I am doing in this entire iteration, what we are doing, we are checking in the entire matrix entries, which is the minimum cost edge. 1 is the minimum cost edge. So what is that 1 indicate? It is 2, 3 or 3, 2. Okay. So but initially when I'll move from first row and then second row. So that's why second row, third column only I'll consider. I'll not consider this third row and the second column, because whenever we are moving here, we will move first row then second row, like that we will move. Therefore we will consider this one. Now I am calling the find function, that is find of the u and find of the v. When I will call the find of the u, so it is find of the 2 and find of the 3. So when I will call that particular function now I will move on to this find function. So what we are doing in a find function, I am checking that whether the parent of the I is greater. What is I value? 2. Whether the parent, and all initially all we made it as a 0. I told you in the beginning. So what is parent of the 2? It is 0. Is 0 is greater than 0? No. Then I will not enter into this. I will say that return I. What is my I value? 2. So what is find of the 2? 2. So then I will call find of 3. What is find of 3? I will come here. What is the parent of 3? 0. Is 0 is greater than 0? No. Then I will not go here. I will go directly go to the return I. What is I? 3. So parent of the 2 is 2 only and the parent of the 3 is 3 only. So got it. Find of 2 is 2 only. Find of the 3 is 3 only. So 2 and 3 are UV. Now I am checking whether the 2 is equal to 3. No, 2 is not equal to 3. Therefore I am calling the union function. Already I told you that what is that union function will do. Union function will combine the two subtrees into a single tree. It will combine the two subtree into an single tree. That means now I am having 2 as a separate node, 3 as a separate node. Now what I can do in order to combine those two, so either I will consider the 2 as a parent of the 3 or 3 as a parent of the 2, means I am joining those two separate tree into an single tree. Getting my point? So 2 is a separate node, 3 is a separate node. Now what I am doing, I want to, what is the union function will do? It will combine the two subtree into an single subtree. So either I will make the 2 as a parent of 3 or 3 as a parent of the 2, means that I am combining the two subtree into an single subtree. That is the function of your union. So what I am doing in the union, so just I am making, you can take parent of I as j or parent of j as I. Both are correct. Both are correct. If you want, you can swap the I and j also. So I am making the parent of the j as I. What is this j? 3. What is I? 2. Now parent of the 3 I am making it as a 2. So see here, parent of the 3 I am considering it as a 2. So this is the, initially all are 0. Now parent of 3 is 2. So parent of the 3 I made it as a 2. Then after this one where we will move, we will go for this while loop. So what is my okay, after this calling union, where I go to the system.println. What we are doing, we are incrementing the NE by 1. Now what is my NE value? It is 2. Initially it was 1, now we have incremented it. Now NE value will become, see here, NE value will become 2. Then I am printing this edge. What is that edge we are printing? 2, 3. We are printing that 2, 3, and also we are considering the min cost value. So what is the min cost? Initially it was 0. Now what is the edge cost of 2 to 3? It is 1. So add, so I'll get it as a 1. So now my min cost is equal to an 1. Then after that one, what we are making, cost of AB and cost of BA, we are making it as a 999. That is cost of 2, 3 and cost of 3, 2, we have to make it as a 999. Why we are making that entry as a 999? Because already we have considered this. Okay. Once again, when I'll go for next iteration, I should not consider this one because already I have considered it. That's why I am making that entry as a 999. That is 2 to 3 and 3 to 2 entry we are making it as a 999, because make sure that next iteration we are not considering once again that same entries, that is the same edge we should not consider. That is the reason once I'll consider that one, I am making them as a 999. Now after the end of this, again I'll come here, then 2 is less than the n, n is 5, 2 is less than 5, no, yes, 2 is less than 5, yes, then again I'll enter here. So again what I'll do means, again I'll consider this entire matrix, okay, which is the minimum, next to minimum cost edge we are considering. So which is the next to minimum cost edge you are having? That is 2, where it is, here. What is this entry? It is 4, 5, 4, 5, okay, this entry 4, 5 I am considering, or 4, 5, 5, 4, both are same. Therefore it is 4, 5 entry. So what is next to U and V? It is 4 and 5. So next iteration, the values of the U and the V are the 4 and the 5. So here I have written with a different color. Okay, next iteration you will get the value of U and the V as a 4, 5. Again I'll call the find function of the 4, find function of the 5. So when I'll move to the find function of an 4 and a find function of an 5, I'll come here. So it is find of the 4. What is parent of the 4? So the change what we have done in the first iteration is this. Okay. So what is the parent of the 4? 0. Is 0 is greater than 0? No. I'll come to the return of 4. Again come to the find of 5. So when I'll say find of the 5, is the parent of the 5 is greater than 0? No. Therefore again I'll go to the return of 5. Therefore when I'll call the parent of the 4 and the parent of the 5, so I am coming here only. So parent of the 4, parent of 5 is nothing but same 4, 5. What we are returning? Same 4, 5. Okay. So is 4 and 5 are the same? No. Is they equal? No. Then I'll enter here. Then I am calling, means now 4 is a separate node, 5 is a separate node. Now what I have to do, I need to combine those two subtree into the single subtree. Those two subtree into a single subtree. Then I'll make either the 4 as a parent of the 5, or I'll make the 5 as a parent of the 4. Okay. Either I'll make 4 as a parent of 5 or a 5 as a parent of the 4. So that is what the union function is doing. So 4 and 5, I is 4 and j is 5. Now parent of the 5 I am making it as a 4. So that is in this iteration, parent of the 5 I am making it as a 4. So p of the 5 will become a 4. So this is after this iteration, this is the changes what is there in the array parent. Then after that one, I'll move to that union function. So after calling this union function, so what we have to do next, we need to print that particular edge. Okay, system.println, increment the any value. Now any value is equal to 3 and print that edge 4, 5. And min cost also we have to consider. So it is previous value is 1, now it is 2, 1 plus 2 is 3. Now min cost value will become a 3. Okay, after that one I'll make 4 to 5 and 5 to 4 entry as a 999. That is this 2 2 wherever we are having, they will become 999. This will also become a 999. Again I'll come here, 3 is less than 5. Yes, again I'll enter this. Again among this entire matrix I'll check which is the minimum edge. So this is 999, this is 999. Okay, don't consider once again the 2. So what is the next minimum cost edge you are having? That is 3. So 3 means what? 2, 4. So next is 2, 4. 2 and 4. Again I'll call find of the 2 and find of the 4. So when I'll call the find of the 2 and the find of the 4, so come to this find of the 2. So is the parent of the 2 is greater than, this is the updated one now. Parent of the 2 is not equal to greater than 0, again return 2. And the parent of the, which one? Parent of 4. 2, 4. Okay, this one. 2, 4. 2, 4. So again I'll call the parent of the 4. What is returned I have to check. So it is parent of the 4. What is parent of the 4? Still it is 0 only. So again return 4. So when I am calling parent of the 2 is 2 only and the parent of the 4 is 4 only. So after calling these two, what is returning? That is the 2, 4 is only returning. Is 2 and 4 are the equal? No. Therefore I will call again the union of the UV. So when I will call union of the UV, what I am doing here is either I will make the parent of the 2 as a 4 or a parent of the 4 as an 2. Anything you can do it, but what we have considered is we have made the parent of the J as an this one. That is 2, 4 are the entries. So it is a parent of the 4, I am making it as a 2. So that is this. This is the new updation what you are doing. Parent of the 4 I have made it as a 2. Okay. Then after this one, again we will print that particular edge, that is system.out.println, and increment the NE. NE is now 4 and print that 2, 4 and make that 3 entry as 999. That means 2 to 4 and 4 to 2, both of 3 wherever it is, they will become a 999, 999. Again now I will come here, NE is the 4 and it is less than the 5. Again among this entire matrix I will find out the minimum cost edge. So which is the minimum cost edge you are having? So minimum cost edge what we are having is now 3 is over. So it is 4. What is 4? It is 3, 4. Next is 3, 4. This one. Next to my this one will come 3, 4. Now I will call the find of the 3 and find of the 4. When I will call the find of the 3, what I will get? Find of 3. So what is my find of the 3 what we are having? So I am checking whether the parent of the 3 is greater than 0. Yes, it is greater than 0. Therefore I will come here. Now I is equal to 3 is equal, I is equal to, and parent of I. What is your parent of the I? 3 you are having 2. So now I value is to return 2. So that is what is returning when I will call that parent function. So parent of an 3, 4. So when I will call find of the 3, what is returned? 2 is returned. Now I will call the find of the 4. When I will call the find of the 4, again what is returned we will see. So it is 4. Is parent of the 4 is greater than 2? Yes, it is greater than 2. So then what is that value? 2. Therefore what is returned again? 2 is only returned. So when I am calling the parent of the 3 and the parent of the 4, what is returned in both the cases? Both the cases return 2, 2. Parent of 3 is also 2. Parent of the 4 is also 2. So both the cases we are getting 2, 2. So is 2 is equal to 2 we are checking here. Yes, both are equal. That means we will not enter into this. Means that this particular edge, which is that edge 3, 4 edge, adding this 3, 4 edge will form a cycle. Adding the 3, 4 edge will form a cycle. Therefore I am getting both the parent as the same value. Therefore not necessary to add that particular edge, which is that edge 3, 4 edge. It is not necessary to add. So again I will go back to here. Are you incremented the value of the NE? No, because we have not at all entered into this loop. Therefore we have not incremented the value of the any, therefore any is still 4. 4 is less than 5, again yes. Then again I'll come here, again I'll check in this entire matrix which is the minimum cost edge. So minimum cost edge is next is 5, that is an 1 and 2. So what is the next A and B value? It is 1 and 2. Now I'll call the find of 1, find of 2. When I'll call find of the 1, it is 1. When I'll call find of the 2, it is 2. You go and check that what it written. So 1 is equal to 2, no. Therefore again I'll call the union of the UV. Again I'll make the parent of the 2 as an 1. Okay, you do that changes. So which is the final edge what you are selected? It is nothing but the 1, 2. So print that one and you will find out what is a minimum cost edge, and then you make the 1, 2 and the 2, 1 as an 999. Again when I will come here, what is my any value now? It is 5. Is 5 is less than 5? No. That means you have added the all the 4 edges what you have required for your MST. So that is the end of your program. So this is the tracing for the same graph. So initially I have added this, then we have added this, then this we have added, and finally one more edge, that is what we have considered. It is not the edge to be selected because it was forming the cycle, because parent of both the 3 and the 4 was the 2 only. Therefore we are not going to select that one. We are not going to select that one. Okay, it is rejected here. Then finally we have selected this particular edge, that is 1, 2, 2. So this is the tracing for that, and these are the some of the examples are there. So in this particular graph, so these are the edges. First we are going to select 1, 3 minimum cost edge. Then among this 1, 3 which is the next minimum cost edge we are having, that you have to check, that is 3 to 6. Okay, we have added. Now among 1, 3, 6, 1, 3 was the minimum we have added. Next 3 to 6 was the minimum. Next which is the minimum cost edge you are having, that is 3, that is an 2 to 3. Next minimum cost edge is 3 to 5. So that is what we will be adding over there. Okay, 3 to 5. Next is 1 to 4, 1 to 4 with the cost of 5. When we need to stop? When the number of the edges are 1 less than the number of the vertices. How many vertices you are having here? 6. So when we need to stop? When the number of the edges will be equal to the 5, we need to stop that one. Okay, and this is the cost adjacency matrix what you are entering, and this is the result what you are getting. Okay, so all of you will execute this lab program and write it in the record. Okay, minimum 3 input and in 3 outputs you need to write for each of your lab program. Okay, thank you.